All right, this week we're going to continue on with our astronomy unit, and we're going to kind of zoom in and focus in on interactions between the sun, earth, and moon. Energy. Don't forget to take notes on the red slides. You should have the notes handouts to go with this. And don't forget to look for the owl and summarize what you learned at the end. So we're going to start off with something that really kind of reveals to us the clockwork of our solar system and how things kind of work together and the orientation of things in space. And that is eclipses. Now, when we're talking about eclipses and a lot of these things that we talk about here, there is a certain way that these things look when we're standing on Earth, but we also need to be able to picture these things as if we're kind of hovering in space over this whole thing and looking at it. So you really need to be able to kind of picture these things in 3 dimensions. The first eclipse we're going to talk about is a lunar eclipse, and that is when the moon is eclipsed. So this is when the Earth interrupts light shining on the moon. It's important, I guess, to understand, first of all, that the sun is the source of light in our solar system, and the moon and the Earth and other planets and things like that do not create their own light. They just reflect the light of the sun, and the sun is really the only thing that creates its own light. So if you look at this animation to the left here, you can see how as the moon passes through Earth's shadow, and that's kind of these lighter parts here, this area here, and this area here is the full shadow. And as the moon passes through there, you can see that the light is kind of cut off from the moon, and and the sunlight is not shining on it anymore. And that's basically the idea of how a lunar eclipse works. The moon is in the shadow of the Earth, so the Earth is in between the moon and the sun and cuts off the light coming from it. This is what it would look like if you were standing on Earth as this was happening. So as the moon passes through these shadows, it becomes progressively darker. And what you're seeing there is actually the shadow of Earth on the moon. That's why it kind of looks curved, because obviously the Earth is round, so it casts a round-shaped shadow. All right, so this is going to require some artistic skills here. You will probably need to get a ruler or just any old straight edge. It doesn't need to be a ruler necessarily. It could be the edge of a book or something like that, but we're going to need to draw some straight lines here. So go ahead and pause the video if you need to and grab something straight and a pencil and then come back to me. All right, welcome back. So you should have something like this on your notes, and so we're going to draw some lines here. First of all, what I would like you to do is draw a line from this big circle, which is the sun, and draw it so that it goes from the bottom of the sun, and then this medium-sized circle here is the Earth, and the small circle is the moon. So you're going to go from the bottom of the sun to the bottom of the Earth, and then continue on to the edge of the drawing area. Now you're going to do basically the same thing, but from the top of the sun to the top of the Earth, and then kind of continue on from there, and those lines should cross over. If you kind of run out of room on your paper, that's okay. After that, now what we're going to do, this next line goes from the top of the sun to the bottom of the Earth. And after that, the next line is going to go from the bottom of the sun to the top of the Earth. And basically what we're representing here is the idea that there is light coming from this side of the sun, and there is light coming from this side of the sun, and we'll see how that kind of casts a shadow in a certain way here. So go ahead and fill that area that you see there, fill in that area nice and dark, and kind of leave the moon unshaded, but fill in that area nice and dark with your pencil. That part that you just shaded in is the full shadow of the Earth. That is where all of the light from the sun is blocked out by the Earth, and that's what we call the umbra. Now you can kind of lightly shade in this lighter blue part here, and this is where there is a partial shadow of the Earth that is blocking out some of the light from the sun, but not all of it. And that is called the penumbra. So as the moon moves through these shadows, it gets somewhat darkened when it's in the penumbra and only becomes fully darkened when it goes through the umbra. That circle there is the moon's orbit, so draw that in as well. All right. Now let's talk about a solar eclipse. So we just talked about a lunar eclipse when the moon is eclipsed. Now let's talk about a solar eclipse. And just take a look at this picture for a second and take a look at this area right here. So what is making that happen to the sun? Well, if you hold up your fist if you're looking at this on a computer, or maybe your pinky finger if you're looking at this on your phone or something, you could hold it between your face and this picture right now and kind of block out some of the sun in the same way that this shadow is blocking it out right here. And I want you to think about that idea that it has to be, in order for that to happen, you have to place something in between yourself, the observer, and the sun. So that's exactly what's going on here. The moon is basically getting in between the Earth and the sun and blocking out the sun. In this picture we see it partially blocked out, but an interesting thing here is that the moon and the sun basically are just the right distance away from us and just the right sizes so that they kind of cancel each other out. The distances and the sizes kind of cancel each other out in a way that both objects basically look the same size in the sky to us. So we happen to live in a very convenient time on Earth where the moon perfectly blocks out the sun, at least a lot of the times when you see a total solar eclipse. All right, so this is basically the geometry of an eclipse now. Now remember, the lunar eclipse, we had the moon in kind of on one side and the sun on the other side, and the Earth was in the middle. Well, now we have the moon in the middle. So if this is difficult for you, remember one thing, and that is just sort of the order of the three objects. In the case of a lunar eclipse, it goes sun, earth, moon. Now in the case of a solar eclipse, it goes sun, moon, earth. So this is when the moon passes between the sun and the earth so that the sun is wholly or partially blocked out. And you can see a little animation on the lower left. This is a partial solar eclipse, not a total solar eclipse, but this is an actual time-lapse footage of what it looks like. In real life, it would go a lot more slowly, but that's an actual video of what it looks like. This is another really cool image. This is an actual image taken from the space station during an eclipse. You can see the moon eclipsing the sun up there, and down here you can see the shadow that it's casting on the Earth. Really cool picture here. All right, so ready to do some more drawing? All right, first of all, let's draw a line from the top of the sun that's going to pass the top of the moon and then connect to the Earth. If they don't perfectly come together the way that they do on this picture, that's okay. Again, we want to go from the top of the sun to the top of the moon, and then from the bottom of the sun here to the bottom of the moon here, and just kind of continue those lines until they hit the Earth. And like I said, if they don't meet perfectly like they do here, that's okay. And then we're going to, similar to what we did before, we're going to do a line going from the bottom of the sun to the top of the moon, and the top of the sun to the bottom of the moon. So you're kind of following this line here right now. Top of the sun to bottom of the moon, and bottom of the sun to the top of the moon. All right. And we are going to fill in once again the dark shadow and the light shadow. So fill this area right here in nice and dark, and then this area here a little bit lighter. And once again, we have the umbra and penumbra. If you want to make your notes look all pretty like this, that's fine, but you don't have to. And again, this is what the sun would look like. This is what the eclipse would look like when you're standing in the umbra. This is what the eclipse would look like if you're standing in the penumbra, only a partial eclipse. Okay, so the next thing we need to talk about here is tides, and I'm sure you're aware of the idea that the tides have to do with the pull of the moon's gravity and all that kind of stuff, but we need to get into some more detail here. Now, first of all, one of the things that you should understand is that it's not only the moon's gravity that causes tides, but it's also the sun's gravity as well. Both the moon and the sun are pulling on the earth and pulling on the water of the earth, so they both play a role here. So tides are the rising of Earth's ocean surface caused by the gravitational forces of the moon and the sun acting on the oceans. So because of that, we get 2 high tides and 2 low tides per day, and that equals 1 tidal cycle per day. This is a tide chart here, and as you can see, if you were to look through this tide chart, the tides are separated by about 12.5 hours. That half hour there is kind of interesting. This has to do with the fact that the Earth is spinning, so obviously if we get 2 cycles per day, that would lead you to think that it would happen every 12 hours, but the thing is the moon is also moving as well, so the moon we need to catch up with it basically, and that takes an extra half an hour. All right, more drawing. Ready? So draw your tides here, and here, and here, and here. Draw those little tidal bulges there. This is the Earth. This is the moon. And this is the sun in both pictures. All right. You can kind of shade those in if you want to. You don't necessarily have to color these. All right. So the one on top is called a neap tide, and the one on the bottom is called a spring tide. And notice how things are lined up here, right? In this picture, the moon is that way, and the sun is that way. And you can imagine that the sun is pulling a little bit on this water, but the sun is really far away, so it doesn't really have quite as much as an impact as the moon does. The moon is pulling this way, so you can see they're kind of working against each other. The sun is trying to get the tides to go this way, and the moon is trying to get the water to go that way. In the case of a spring tide, you have both the moon pulling in this direction and the sun pulling in this direction. So they're working together in this case. And so in neap tides, the tides are not as extreme. They're kind of towards the middle. You don't get really low tides, and you don't get very high tides. Whereas for a spring tide, the high tides are extra high and the low tides are extra low. All right. So this is all about gravitational pull here. This is the idea of working against each other or working together. So, face of the moon. We've all seen the moon and the moon face, and an interesting thing is that whenever you have the full moon, it always kind of looks the same. We have that old man on the moon kind of image that we see up there. And by the way, different cultures have different things that they see in those moon shapes. But the point here is that we see the same thing all the time, which tells you something. That tells you that it is the same side of the moon that we are always seeing. And that's kind of weird, right? Because the moon is spinning around and it's going around us and stuff like that. You would think that you would see different sides of the moon. Well, I would like to show you now the other side of the moon that we don't see. So this is the face of the moon that we normally see, and this is the other side. Notice the difference here. This is kind of interesting. One main difference that really sticks out to me is there's a lot more craters on this side of the moon. We'll talk about that a little bit more in class, but that's what the other side of the moon looks like. By the way, notice I'm not saying the dark side of the moon here. There isn't really a dark side of the moon, as in a side of the moon that's always dark. Just like on Earth, there's always one half that's dark and one half that's light, but that half changes. So here's why we always see the same side of the moon. Well, it takes the moon the same amount of time to rotate around once as it does for the moon to go around the Earth once. So in other words, a moon year, we could call it, I guess, the time that it takes to go all the way around the Earth, and a moon day, the time that it takes to rotate on its axis one time, are exactly the same amount of time, and that's about a month or so. So this is an interesting coincidence. Well, it turns out it's not a coincidence. It has to do with the fact that one side of the Earth, of the moon, is kind of has more mass to it than the other side. And because of that, every time the moon spins around in the past, every time it spun around, when the side with more mass was facing the Earth, it would slow down a little bit and grab onto the Earth a little bit more. And over time, that slowed it down to the point where it was locked in, and so that one side is always facing the Earth. All right, so let's talk about phases of the moon now. You should know a lot of these. So, more drawing. Ready? All right, we'll start off with the new moon, and that's when the moon is completely dark. So in this case, the sunlight is coming from the right-hand side of the picture here, from over here on this side. So fill in that circle completely. This is basically what a new moon looks like. Actually, new moon, you can't really see it at all, but it's hard to have a picture of that. All right, the next phase of the moon is going to be a waxing crescent. Now, I want to pause here to kind of take note of the different words that we're going to see here. Basically, when we talk about the phases of the moon, there's two parts to it. There is the part that tells us what it's doing, whether it's getting bigger or smaller, and the part that tells us how big it is right now. So waxing and waning mean getting bigger and getting smaller. Waxing means getting bigger, waning means getting smaller. Or you could think of it as waxing is moving towards a full moon and waning is moving towards a new moon. Now, as far as the other part of the word, where it is right now, we have crescent, gibbous, new, full, and quarter. So crescent basically means that it is smaller than half. Gibbous means that it's bigger than half. Full moon is the entire moon, and new moon is no moon at all. And the quarter moon, this is kind of an interesting one. This is when we see half of the full moon lit up. Now, why don't we call it a half moon? Well, if you think about it, half of the moon is always lit up. When we see a full moon, we are seeing the lit up half of the moon. When we see half of the moon lit up, we are actually only seeing a quarter of the moon. Again, when we see the full moon, that's seeing the lit up half. When we see half of the moon, we're seeing half of that lit up half, and so half of a half is a quarter. I know, that was a lot of math. Anyway, so we have our waxing crescent. Waxing crescent looks like that. We have the first quarter. First quarter looks like that. We have a waxing gibbous, getting bigger, and it is now bigger than half. Looks like that. We have a full moon, which looks like that. We have a waning gibbous, so now it's getting smaller. We have a third quarter moon. And last but not least, we have a waning crescent. Something to notice here is the idea that when the moon is waxing, we always will see the lit up side of the moon on the right-hand side. And when the moon is waning, we will always see the lit up side of the moon on the left-hand side. So here's a little extra credit opportunity for you. If you can go out and see the moon and take a picture of it and post it, then you can and tell me whether it is waxing or waning based on which side of the moon is lit up. All right. Help me out here. Let's practice these. That's the new moon. What's that one? Waxing crescent. What's the next one? First quarter. What's the next one? waning gibbous, next, full, next, waning gibbous, then we have last quarter, then waning crescent. Caused by the tilt of the Earth's axis. So in other words, what that means is that because the Earth is sort of tilted, as you can see in this picture, sometimes we in the northern hemisphere in the United States are kind of tilted away from the sun, and sometimes we are tilted more towards the sun. And this tilt is a 23.5 degree angle from sort of straight up from the plane of the orbit of the planets. All right, so fill in these blanks as we go. We have spring is during that time, summer is during the time when we are tilted most towards the sun, autumn is when we're kind of in the middle, and winter is when we are tilted most away from the sun. Now, each one of these seasons has a specific beginning point, and that's what all these are. So the beginning of summer is called the summer solstice. The winter solstice is the beginning of winter, and then we have the vernal equinox, which is the beginning of spring, and the autumnal equinox, which is the beginning of fall or autumn. You might ask why can't they just call it the spring equinox? They do call it that sometimes. Vernal, if you know your Spanish or your French languages and you know the color for the word for the color green, that's vert or things like that, and so that's actually where that comes from. Vernal means green, and of course green is a good color for spring. All right, so the summer solstice is the first day of summer and the longest day of the year. The winter solstice is the first day of winter and is the shortest day of the year. The vernal equinox is the first day of spring, and there is equal day and night. Notice the word equinox, right? Equa, like equal, and nox actually means night, so that word literally means equal night, and the reason why they call it that is because the time when the sun is in the sky and the time when the sun is not in the sky, otherwise known as day and night, is equal during these 2 days. Last but not least, we have the first day of fall, the autumnal equinox, and we have equal day and night again. All right, so lots of stuff in this one. Talking about the sun, earth, and moon and their interactions. We talked about eclipses. We talked about a lunar eclipse, and we'll go over this in class and we'll use models and things like that. But remember, on at least the most basic level, the thing to remember is kind of the order in which the 3 objects are in order to create these eclipses. So we have a lunar eclipse is the sun, earth, and moon with the earth in the middle. Solar eclipse has the moon in the middle. And we talked about this idea of the umbra and penumbra. Those are some terms you should remember. We talked about tides. Tides are caused by the gravity of both the sun and moon. We have spring tides, which are the moon and sun working together, and neap tides, which are the sun and moon working against each other. We talked about the moon phases. Waxing is growing, waning is shrinking. We have gibbous is big, crescent is small, and quarter is half. It's one of the few times where you get to say that. And full moons is the whole moon, and a new moon is we don't see any of the lit up side of the moon at all. We talked about seasons. They're caused by the tilt of the earth, not the distance from the sun. And we talked about solstices and equinox, and these are the beginnings of each season, and that's all you need to know. We'll talk about it some more in class, and I'll see you then.